In this video, I'd like to talk about something called pathfinding. Now, pathfinding is one of the fundamental things that AI need to do in real-time games. The idea of pathfinding is essentially a pretty simple concept. It's how do I move from one position to another position? If this is where I'm standing, how is it that I can traverse my world to get to my goal? For a lot of games, this can be pretty simple. When we build our very first AI or our very first video games, it may be something as simple as, well, that's easy. Just move the AI in the direction towards the goal. Figure out when we're close enough to the position of the goal, and then stop moving. And it may be as simple as that. But once we start to add in some more complex elements into our game, we'll find that pathfinding isn't always quite so simple. Commonly, games have real-world obstacles, or digital versions of real-world obstacles. This AI could be in a room over here, and they need to move through a small hallway to get to their goal. Something along these lines. If we build a level like this, then our initial code that runs our AI directly towards the goal won't work anymore. This is where we need to come up with a proper pathfinding solution, or something that's a little more, a little smarter than just moving towards the goal. One of the ways to represent a world like this is using some sort of grid-based pathfinding. Grid-based systems work by breaking the world up into a complete grid, and you would essentially have, let me draw these as small squares. So you would essentially have a grid that looks something like this, that sort of fills out our entire world. And you can kind of imagine how this grid would just fill out the rest of this room, as well as the hallway, as well as the second room over here on the right. And grid-based games like this we see all the time. Grid-based pathfinding will be used commonly, well, obviously, for things that have a grid-based gameplay. You see this in a lot of RPG games and tactics games where I have a unit that's standing at this exact position and I'm going to move, 2 spaces north. And grid-based systems like this we see all the time, not only in video games, but also in tabletop games and in board games. Grid-based systems is how Dungeons and Dragons works, as well as tons and tons of other board games. Grid-based systems can be a good solution, but they do mean that the gameplay in your game typically needs to be something that is also grid-based. It's a little awkward if your player can run around freeform, but your AI is moving in all these sharp angles and sharp directions, right? Another common method for representing how our AI can move through the world is using something called graphs or nodes. A node-based pathfinding system would work by placing a series of points around our world which represent areas or places where the AI can walk and move to. What this does, and how a system like this works, is it actually connects these using a graph under the hood. So we would end up with something along the lines of this. And one of the first exercises that you typically do when you're doing pathfinding systems is to build a node-based pathfinding system similar to this. One constraint that this does have, very similar to the grid-based system, is that our AI is typically confined to only walk on those specific nodes. For example, I don't really know or have a good representation that says that my AI can even stand at this position or stand at this position, right? I don't really know where the walls are or where line of sight's being blocked or things along those lines. So it doesn't give my AI a lot of context in how it can navigate around the spaces. So let's try and go one step even more complex. A third very common system is using something called nav meshes. Nav meshes, which is short for navigation meshes, represent the world using 2D planes, typically 2D planes, that sort of show us or tell our AI the entire space where an AI can walk. And in a simple example like this, with 2 rooms and a connected hallway, this might be represented by 3 different meshes. The first mesh would represent this room over here. The second mesh would represent the hallway. And then the third mesh would represent this room over here. Our meshes are actually full, so they'd probably look something more like this. This is a full 2D shape. So here's 3 navigation meshes, which represent the areas in which this AI can move. Notice how I drew the edges of these meshes a little bit off of the wall. Typically, navigation meshes are actually slightly off of the walls in our video games because our AI and our characters are not infinitely small. These meshes represent places where an AI can actually stand, and we can't really stand inside of a wall or inside of, right up against a wall at this position. Typically, we have to stand here in slightly so that our shoulders aren't overlapping or going into other geometry. A navigation mesh like this represents that all of these colored areas are places where our AI can move to. This navigation system using nav meshes is one of the most standard methods for doing navigation in 2D worlds or 3D worlds. It relies on these 2D planes, and it typically also requires a generation process. So typical nav mesh systems will first have you author your content or build your worlds. Then we'll have you generate the navigation meshes in some way, which can be a little computationally expensive, so that typically takes a little bit of time. Navigation meshes are typically then saved or stored to a file, and then they can get loaded back up when the level gets loaded. Then our AI sort of has the context of, I can walk anywhere within these spaces. These 3 methods, either a grid-based system, a node-based system, nav meshes, are 3 of the most common methods of pathfinding. There are other solutions out there, and I definitely encourage you to think about the best methods for creating pathfinding based on the style and the gameplay within each project that you're developing.